Malware analysis is the process of understanding the behavior and the purpose of any suspicious file or a URL. This process is divided into two primary approaches: static analysis and dynamic analysis. Static analysis involves examining the code and the structure of an malware sample without executing it. The goal is to gather the information about the malware, such as its functionality, the data it manipulates, and its intended targets. The key concepts in the static analysis are hashing, embedded strings, and PE header. Hashing generates a unique fingerprint or a hash of a file. This fingerprint can be used to identify a known malware by comparing it against a database of known hashes. If a file hash matches with the known malware hash, it's likely that the file is malicious. Hashes are also useful in verifying the integrity of files. Embedded strings are the sequence of readable characters embedded within the malware binary. These strings can reveal clues about the malware functionality, such as URLs, file paths, IP addresses, and error messages. Analysts often search for suspicious strings that might indicate the malicious activity, such as references to a system commands. PE header is a crucial part for the Windows executable files. It contains metadata about the file, including the information about sections and other attributes. Dynamic analysis. It involves executing the malware in controlled environment, such as sandbox, to observe its behavior. This approach helps in understanding how malware interacts with the system in real time. The key concepts in dynamic analysis are monitoring changes and behavior monitoring. In monitoring changes, you track the changes to the files and directories malware might create or delete or modify. You also observe the network activity, communications, including any DNS request, HTTP traffic, and attempts to connect to a remote servers. Behavior monitoring is to monitor any API calls made by the malware to understand what actions it's performing. For instance, calls to open process, write process memory, and create remote thread might suggest code injection techniques. Observe the changes to a memory, such as a new regions being allocated, modified, or freed. Malware often uses techniques to detect if it's being analyzed, such as checking for debuggers, virtual machines, or sandboxes. Here are some tools for malware analysis, both for the static analysis tools and dynamic analysis tools. TriadNet is a file identifier that analyzes a file's binary signature to determine its type. ExeInfoPE, a tool for analyzing Windows PE or portable executable files. It provides information about the compiler used, the packer or protector applied, and other file attributes. Bin.txt, a simple tool to extract ASCII and Unicode strings from a binary files. Strings. It's similar to the bin.txt, the strings command line, and extracts printable characters from binary files. XOR search, a tool designed to search for strings in files that may be XOR encoded. CFF Explorer, a tool for exploring the structure of PE files. It allows for detailed analysis of headers, sections, and resources. PE Studio, a powerful tool for static analysis of PE files. It provides detailed information about the file, including the potential indicators of malware, suspicion sections, and non-malicious signatures. HashMyFile, a small utility that allows you to calculate MD5, SHA1, CRC32 hashes for one or more files. Now let's jump into the dynamic analysis tools. Regshot, a registry snapshot tool that allows you to take two snapshots of the registry that and compare and to detect the changes. Auto runs display all program configured to run during the system boot up or login. It is useful for identifying persistence mechanisms that malware might use to maintain a foothold on a system. FakeNet, dynamic analysis tool that simulates a network environment, capturing and redirecting network traffic. The traffic that has been captured by FakeNet can be analyzed into Wireshark. Process Monitor, or the ProcMon. It is a real-time file system registry and a process activity monitoring tool. ProcDot, a tool that visualizes the data captured by a process or a monitor. It creates a graph that shows the relationship between the processes, files, and registry keys. There are furthermore techniques for the malware analysis, such as reverse engineering, memory analysis, and automation. As memory being the main part that gets infected under the malware attack, understanding and analyzing the memory can be much more effective during the malware analysis. And the reverse engineering, when you reverse engineer a exe file or the malware, you can understand its properties and the task it is trying to reach. You can use tools like Ghidra and IDA Pro for the reverse engineering. So these are the major 5 areas that you should focus during your analysis process. You should check on the modifications if they are made to the file system or the registry. You should check the network traffic that is generated during the malware. And you should also check if the malware auto starts and any other process that it launches.